Afternoon. This is Lee McWhorter, cybersecurity instructor for WazU. Welcome back to the part two of the system administration course that began a week ago Monday. Last week, we covered the first three lessons in our course. And so this week, the middle week of our 3-week cycle, though don't forget, we do have spring break next week. So this is actually a 4-week cycle. But nonetheless, following the model, since we won't hold a workshop or one-on-ones, etc., during the actual spring break week, we will be covering the next 4 lessons, sort of the middle heart of the course. And then we will save for after spring break, when we come back, the last 3 lessons to wrap up the series. So we had, just as a quick review, we had covered the basics of system administration last week, some best practices, repeats of some terminology, a little bit more discussion of the OSI model. We had talked at great length about cloud, virtualization, and various tools, including the packet tracer tool. And I see at least one of you has turned in that stuff, and that's good. Hope you had fun playing with the packet tracer. It's kind of a neat tool and very useful to have in your arsenal. And then we finished up with lesson 3, which was all about different types of network components, both just sort of our standard components that we find on our networks, routers, switches, servers, clients, to security-related network components like IDS and SIEM, if you remember all those wonderful acronyms, right? And then we had some, of course, some more best practices. So we're going to blow through a good chunk of this stuff, and if we spend a little bit of time, I'll get to some demo and a little bit of showing some additional examples when we get into lesson 5, which is one of the more hands-on lessons, because we cover shell scripting. But before getting there, let's hit lesson 4. Lesson 4 is on operating systems. It's important both for system administrators, but obviously for cybersecurity professionals as well, to know as much as possible, actually, but at least an overview about all the different operating systems that are out there. And our focus in this lesson is mainly on the ones that we see in sort of mainstream, broader use today, though there are some variants of things, particularly when we talk about the Internet of Things and embedded systems, as we've discussed in different places. And we'll discuss, I believe, a little bit more on the last week of this class even as well. But in many cases, even some of those languages are actually variants of one of the 3 main families we discuss here in lesson 4. And so it's important to understand operating systems because of the sheer fact that that's, what the clients, the various users in our organizations are using, usually Windows, Apple maybe, some form of the Linux, Unix family. And then we also, of course, run our servers on these operating systems. And many of the embedded and IoT type devices are running, in many cases, variants of Linux, stripped down to solve the purpose, though there are a few other what we call real-time operating systems that are also in use, but we don't really go into much detail about those in this part of the class. Our main focus is on the 3 main families that we really kind of see in mainstream broad adoption around the world. And those include the Windows family of operating systems, the Apple family of operating systems, and then what we can refer to as the Linux/Unix, or sometimes is referred to, you'll see it in literature and online, asterisk NIX, the asterisk being a wild card. If you remember from Network Foundations, it's the wild card character when you type in command lines. If you wanted to delete all PDFs, for example, you'd say asterisk.pdf, right? Whether you used DEL for the command prompt of Windows, or you use remove rm space asterisk.pdf. So asterisk's a wildcard for anything. And so you'll see very often the Linux Unix family is asterisk Nix, the Nix family, because they are similar, obviously, in many ways. And we'll talk about that. I will say this up front before we dive into each of the individual families. There is a large argument that could be made that there are really only 2 families in the world, and one is the Windows family, and then the other would be the asterisk.nix, or the Linux, Unix, etc. family. And the reason for that is because that when you really dig down underneath the hood of modern Apple, Mac OSs and iOS and etc., what you will find is a Unix kernel. And so we could technically, and some do, but it's the reason that we leave Apple broken off separately is mainly for a couple reasons. One is that Apple has a unique interface, even though a GUI is a GUI, I guess, at the end of the day. But there's a lot of sort of known Apple-ish kind of tendencies and certain features that they've built into their operating system. And while there is a terminal or a command prompt on Mac, most Mac users never venture there. Especially sort of the average just home user or a work user in a marketing or graphics department or whatever they may be using a Mac in. And because there is such uniqueness in their interface and their family of products, even though at the core it's based on a Unix kernel, we treat it as a separate family. And there's also even licensing reasons for that. Apple, even though Macs today run on Intel chips and use the same kind of RAM and hard drives and internal components as any other, say, Windows PC, you technically can't just install the Apple OS onto a clone Windows PC. It's against the license agreement. According to Apple's license agreement, you can only run Apple software, their OS, on top of Apple hardware. And so that is another reason from a legalistic point of view why we keep the Apple family broken out. Plus, they have built a whole series of things, so they do qualify, at least in the broadest sense, as a separate family. So, but we'll start with Windows. Windows is still, especially at the desktop level, Windows is still the sort of the huge thousand pound elephant in the room. You walk into most companies around the world, and you're going to find Windows PCs running the vast majority of operations. They will, in many companies, be a mix of things, of course. But when it comes to, like I said, the desktop operating environment, the system that most people sit down, log into, interact with their applications, they're generally running a Windows version, and especially in the enterprise. Working with a lot of Windows servers for various things like print servers and file servers. And of course, Windows has its own version of what's called LDAP, or lightweight directory access protocol. They call theirs Active Directory, but it's basically what allows, and maybe some of you have had this experience where you work, you log into your computer, and when you log into your PC, you're actually logging on to the network, and you get access to various printers and shares and things that you are enabled without having to log into each of those individually. And so it's a very popular in that corporate world still, and the vast majority of home users actually are still buying, even though Mac has grown over the last few years, its market share in the desktop and laptop space, and of course has, very big positions in the mobile space. Windows has really dominated the desktop at home and in the corporate and small office world. Windows has a whole series of languages, of operating systems. You will still find in this day and age, one of the oldest that is still out there on any regular basis is Windows XP. Windows XP has been end of life, as they call it, for a lot of years, but it's still embedded into things like, one of my favorite things is the vast majority of ATM machines around the world, or if you rip open the case and look inside, you'd find a Windows PC running most of the time Windows XP. The companies that built those products and embedded that Windows XP operating system to drive all that have not actually upgraded yet, or they're in the process of doing so, and have been paying Microsoft a large amount of money for support and continued security updates, even though for the average user, if you still happen to have a Windows XP machine, it won't be getting updates. As a matter of fact, every time you boot it up, it'll come up with a little warning saying, this is out of life, you should update. And then, of course, there are other flavors around. Some of you may still be running Windows 7. Windows 7 is due to be end of life before much longer. But nonetheless, it's still a pretty dominant installed OS, particularly in the enterprise level. Most home users, if they had a Windows 7 machine when Windows 10 came out, they were able to upgrade for free. And of course, if you buy a new PC these days, it's going to come with Windows 10. And Windows 10 is the kind of supposedly the last version of Windows we will ever have. Though, of course, they update it and change it and put out new versions. They just will supposedly never change the name. Windows 10 is going to be the OS. And once you buy a PC or have upgraded to it, then you will stay, free support forever. That's the idea, is that it will continue to evolve and they will push out updates. And then, of course, Windows has a whole series of server products. You will still find some older, sort of, if you find XP out there still in a small chunk of the market in certain niches and certain sort of developing countries and certain niches, certain industries that haven't put the money into upgrading because of invested legacy systems. You will also still find the occasional Windows Server 2003, which is basically at that same level. And then there's a number of other versions going through Windows Server 2008. Windows Server 2008 R2 is called the Released Candidate 2 or Release 2, sort of an update in after it had been put out. And that has got a pretty good install base. And then more and more people, as they move to Windows 10 in their enterprise, are also moving to Windows 2012. Windows, I'm sure they haven't promised to not keep putting out different server versions. So we will probably see additional server versions come out in years, but we'll continue to use Windows 10. Windows does have an embedded product as well, and various variants of its products. Even though just sort of out of the box, if you get the average Windows Server product and install it, you'll have a GUI desktop that'll look very much like what you would expect on a Windows, say 7 or 10 desktop interface, depending upon the level. But they do sell a version called Windows Core, Windows Server Core. And what it is basically the GUI is pretty much stripped out of it. And funny enough, you're running more of a PowerShell-based command line to issue your commands. And the reason for this is because a lot of administrators don't need that whole GUI overhead when they're just running a server headless, stuck in a rack somewhere or in a blade or even in the cloud. And then Windows also has an embedded product. There was for a while a Windows Mobile, a Windows Phone, but Microsoft had a very bad run at that. It did not work very well for them. They had even gone so far as to buy the phone arm of Nokia and put out Windows phones, but they never gained any traction in the marketplace, and ultimately Microsoft had to pretty much write that off. And so while their embedded product could, and sort of some of their stripped down versions could be used to power devices on a mobile level, it's not what you're likely to see. And we'll talk more about that as we move into the other two families. But they do have a family server, different variants of it, different versions, the Windows operating system for desktop clients, an embedded product, and certain specialty versions, and you can get into all kinds of subversions as well, as we talk about in the lesson. Most people, if you just go buy an average computer at the store, for cheap, a new laptop, a new desktop, you're going to get Windows 10 Home. But they do also have the professional version, which they target more at the enterprise level and small businesses. They also have an enterprise version. As a matter of fact, if you are ever needing to play with a Windows 10 machine, you don't want to mess with your own, you want to try something out, try out some software, or try it out as a target, maybe in security practice, the Windows provides both a trial of that you can download a CD or an image to install Windows 10 Enterprise for 60, 90 days or something like that. And then they also provide, which is even kind of more interesting if you're wanting to use it as a target or test bed, is they provide a VM that you literally can download for VirtualBox or VMware, import it into your virtualization package and boot it up. And it already has some of their developer tools. It has some stuff on it so you can experiment, but it's a fully licensed for, the trial period and running copy of Windows 10 Enterprise. And they update that fairly often as they update Windows 10. And so you can download a copy of that and use it as a test bed for whatever reason. I actually recently used it as a fresh Windows 10 machine that I could do some installs on, so I could shoot some screenshots for something I'm working on. So the Windows family is the one that most people know about. But then the next big sort of consumer one that most people think about would be Apple, would be Macintosh. So we are actually officially called the Mac OS now. And then Apple has its own family. They have their core Mac OS. They have stopped naming it based on numbers some time back. For a while, they were naming the versions of Mac OS based on cats, and I mean like puma and leopard and snow leopard and things like that. Then they moved away from that. That was in the OS X days, as they were calling it, operating system 10 or OS X. And when Microsoft finally brought out Windows 10, not too long after that, Apple changed to being just Mac OS, and then they started to use place names, particularly in California. So we've had Sierra and different other names, El Capitan. These were names named after places and national parks and whatever in the area that they've used as their naming scheme. But they do have, in some way, and they have a server, but it's not really a separate server product anymore. It's kind of an add-on that you can get out of the Apple Store to add on to a copy of the Mac OS and upgrade it to add some print and file sharing and other features, user management, so that you can have it be a server. Last time, gosh, was years and years ago that I had anything to do with a Mac server in a company I worked for in a former life, before my own business and teaching. We had a design department, and our design department was all on Macs, and all of them had their own Mac server, and we actually had them isolated off on their own subnet because, at least back in the day, especially with the Apple Talk protocol, Macs could be pretty chatty to talking to each other, and so we wanted to keep that traffic off the rest of the network. And so we had set them up basically in a VLAN, so that traffic didn't, hop around and hit every other Windows machine or Linux server in our network. But they technically have a server product, but it's not really a separate product. It's an add-on to the underlying Mac OS. And actually, Mac doesn't have as many variants. They don't have like the home and professional. They have Mac OS, and the versions are based on those place names. And so you would, generally speaking, assuming your machine can do it, you would upgrade to the latest version. I finally, with one of my older Macs, for example, I'm in the Mac OS level, but I'm now, I think 2 behind on that machine, because at some point, of course, even though they're not changing the name except to give it a new name, and the same would happen for Windows 10 at some point for machines, you just reach a point where, the features that are being added, the new functionality, they finally say, okay, older machines, older processors, older model types aren't supported. And so you stay at the version that you could borrow, the farthest version you could go to. And this happens actually pretty commonly across the Mac line, because once you get beyond the Mac OS that drives their laptops and their iMacs and their desktop systems, you then get into all of the other, like iOS. iOS is their embedded operating system that runs on their iPhones and iPads. And the same kind of thing is they continue to upgrade from the original iOS now into the 11 and 12, whatever dot range that they're offering now as the latest version of iOS. If you have an older, iPhone or iPad, then at some point you won't be able to upgrade anymore because it doesn't support. Maybe they added some new features that need a new chip or more RAM or whatever. And so, but they will, the device will continue to operate with that older iOS. But they definitely have, those products. And then in addition to that, they have watchOS, which goes for their Apple Watch. They have tvOS, which goes for their Apple TV products. I have a couple of those in my house. I'm a big fan of them. But there's all kinds of different sort of set-top boxes, the Chromecast and the Rokus and things like that. I generally have them all, being the kind of geek that I am. But I kind of like, and for the most part, work the most with the Apple ones. But if you did, like I said earlier, if you dig deep underneath the Apple OS stuff, you will find that all the OSs, whether that's Mac OS, iOS, tvOS, watchOS, that underneath there's basically a Unix core to it. And Steve Jobs can be thanked for that, because back before Steve Jobs came back to Apple, he had, of course, been forced off the board at some point in in earlier days of the Apple history, and had gone on to form another computing company called Next Computing and built an OS based on the AT&T Mach kernel, which is a Unix kernel called Next OS. And then he also formed Pixar, which ultimately got bought by Disney, and he ended up on the Disney board, but he got brought back to Apple in their kind of down days. And one of the first things he insisted, which needed to be done, was that they needed to take the older Mac OS 8, 9 level of stuff that they had been working on that was proprietary and had really gotten long in the tooth, and they needed a new OS to drive new devices. And so they basically built their new OS on the underlying kernel of what was the Next OS. So we have, if you launch the terminal on a Mac, for example, it's 99.9, there's slightly differences, of course, the way Apple does things. But for the most part, you're just like if you open the shell onto an Ubuntu machine, you're at the bash prompt. It's a bash terminal, and you can issue all of those basic commands for Linux, Unix, like ls and remove and change directory. And all of them, like we learned in Network Foundations, work just exactly the same on a Macintosh at the command line as they do on, say, an Ubuntu or other flavor of Linux. And so the big difference, like I said, is their whole ecosystem of the Apple stores for different devices, the fact that they do have a family of operating systems that do integrate and work well to each other. If you can easily throw something from your phone up on your iPhone and your iMac, or because of that commonality of underlying OS. And so while it could be argued that it's really a Unix OS at the core, it's treated as a separate family because of the legal restrictions of it having to run on Apple hardware and the complete ecosystem that they built there. And so you will find it is probably the second biggest. I mean, it is the second biggest desktop installed operating system. Then the Nix family, the Asterisk.Nix, is the last. This incorporates the true Unix, the Unix flavors that are out there. Years ago, when Unix was developed, they were proprietary versions, different entities from Bell Labs, AT&T, SCO, SCO Unix, and other companies built different flavors of Unix, and they charged a fair amount of money to sell that OS back in those days, and it would go usually on sort of like a mini computer or even a mainframe, like IBM's AIX is a Unix flavor that IBM built years ago that powers a lot of their mini computers and mainframes. And the big difference is that while you can put a graphical user interface on top of a Unix installation, and we do see that even in the Linux world, the reality is that a lot of the work on Unix machines are done at the command line, and that's because, especially if we're running servers, we don't need all that GUI. Nobody's going to sit down and fire up a word processor or a browser on that machine. They're going to be sitting in a rack somewhere, or in this day in the cloud, they're going to be spun up virtually like VMs you've built in previous classes. And you'll be running that virtual machine up on Amazon or Google or Microsoft's platform. Now, Linux is basically an open source clone of Unix, and it was designed so that there wouldn't be the issue of the high licensing fees, and to get a version of an operating system that had that level of robustness and multi-user capability out to a broader audience without having to pay thousands or tens of thousands of dollars in license fees. And so when we think of Linux, we're really talking about the core kernel that has been developed by the Linux community and Linus Tokador. And then on top of that, lots of other distributions, as we call them, of Linux exist, like Ubuntu that we've worked with. The company that might ring a bell, Red Hat Linux, has carved a little bit of a niche for themselves into the enterprise space as a Linux flavor. And there are just countless other flavors, SUSE, S-U-S-E, older ones like Yellow Dog and Slackware, just on and on. I mean, there's so many, Gentoo, Mint, CentOS, these on and on. These are all different OSs, but what they all share, if they're Linux, they share that same Linux kernel. But then the difference is what they layer on top of it, what add-ons they put in, and then how they configure it. Ubuntu particularly has tried to make it much more user-friendly, even though you can get a server version of Ubuntu that boots to a command line. If you just sort of download the standard Ubuntu desktop, it boots to a nice GUI. It already has Firefox and certain things installed. And so they, tried to set that up. But at the core, they're all Linux or Unix based kind of systems, or Linux based systems. And that means we can run many of the same applications, if not all of them, on any flavor. So like the Apache web server or Ninjix web server could be deployed on any flavor of Linux for the most part. And as well as most Unix flavors. There is still SCO and Solaris and a couple that are out there in certain places, particularly powerful engineering or graphical workstations, CGI kind of workstations, or mainframes and mini computers still. So it's important to know about these families. Now, the other place, though, is that it's kind of weird because we have a few standalone Unix flavors that are still owned and have to be bought and licensed. We have a whole ecosystem of Linux flavors that are all open source. And so, but funny enough, if you really get down to it, while Windows particularly dominates the desktop, at the end of the day, probably, especially if you count the way I'm fixing to, the largest install base of operating systems in the world are actually Linux based. And that's because half of you, probably one of two of you in the class, one out of two of you in the class, you have or more have an Android phone. Well, Android is a Linux operating system. You literally, if it doesn't already come with it on your phone, can install a terminal, a bash shell, basically open it up, and you can start typing ls and basic Linux commands just like you could on Ubuntu or on any other flavor. And so Google basically took the Linux kernel and some of the Linux community stuff and then built Android, and Android itself is effectively open source. It kind of has to be because it's based on the underlying operating Linux operating system and kernel. And so Android powers more smartphones than any other, especially around the world, with Apple, of course, iOS being the next dominant flavor for a phone. And so when you count up all those mobile phones, then there's just all of a sudden there's more of those than there are computers by a long shot. And then one other piece that you have to throw in is that for years it's been said, and it still remains true, that the vast majority of the web is powered by Linux. Most of the time, either running Linux. We used to have a phrase called LAMP a number of years ago. It was Linux, Apache, MySQL, and PHP. And that's how a large number of sites, especially dynamically database-driven sites, were built. Today, the ecosystem has broadened. There's more than just PHP. A lot of people have moved on to other frameworks to build web applications. But underneath, it's still generally a Linux server running either Apache or Ninjix, or a few other flavors of web servers that are out there. And particularly beyond the fact that even in the early days of the net, companies would set up, a Linux machine, and set up a web server on it and start doing the web. Today, of course, we have the cloud. And if you have a choice, in many cases, and what you need is a server to handle email or handle a website or whatever, are you going to spin up what costs you money, a Microsoft server with a GUI, or even the core version that doesn't have the GUI? It still costs you money. It's a license fee. Are you going to spin up that VM and pay that fee for it? Or are you going to spin up an open source free copy of Linux? Well, even on Microsoft Azure, the vast majority of virtual machines, virtual servers that they are hosting, or at least over half, somewhere between 50 and 60, so maybe not vast majority, but it is on the other platforms like on Amazon and Google. It's almost all Linux machines that are being spun up. But even Amazon, the Microsoft Windows company, they are spinning up more. People are spinning up more Linux VMs. And Microsoft has really made a large number of strides in the last few years of really sort of coming on board with the Linux bandwagon, supporting it in their cloud, supporting it with more and more of their products that they put in cross-platform. So when you look at the huge growth of virtual servers in the cloud and realize that the majority of those are Linux, and then you look at the huge growth in Android operating system and tablets and devices and embedded devices and Internet of Things, Linux is actually the largest installed OS on the planet. But it doesn't really show up very often on the desktop at home or even in the corporate world. More often, if it's going to show up on somebody's desktop, it probably would be in the corporate world. For example, a lot of security people, their main desktop will be Kali Linux or Parrot Linux or one of the security distributions, so that they have a secure OS. They have a Linux flavor. They have all their tools available to them. And even if they're running a Windows or Mac machine, they're probably firing up a VM that they bridge out so they can do their work. And so you will see, Ubuntu in some cases in certain roles being used but the vast majority are Windows. So if you look at the desktops at home users, it's Windows, a decent chunk for Apple, and then a teeny chunk. There's very few people around the world who at home are using Ubuntu or whatever flavor of Linux as their main day-to-day operating system. Most are using Windows or Mac, and the same applies at the corporate level, with a little bit bigger chunk of Unix/Linux machines there. But even though Windows dominates that small office and enterprise office network with the desktop of Windows and the Windows Server products driving a bunch of print and mail servers and directory servers and things like that, as you head out to the internet, the vast majority of internet, email, web, other types of services, and they are being powered, database servers, etc. They're being powered by Linux. And so along with Android, Linux is actually huge. And it becomes critically important for us to understand Linux in our field because of so many of our tools, of course, run on Linux natively. So then the lesson ends up with, or finishes up with a bunch of threats. Every OS has faced threats. You have some links in there to go visit some of the online sites that list and database all the different threats and vulnerabilities that have been found. And so you'll have to do some research on that, and I'll leave that to you. So what I want to move on to, because I took more time than I thought on the operating systems, but it's important to understand where they play and how they come in, and because we need to know a little bit about all of them, because we're going to experience them as part of being a security. We're going to have to defend them, or if we're doing pen testing, we may have to know how to potentially attack them. So it's good to know all about those different operating systems and the ones you might run into in the wild. Lesson 5 is about shell scripting. And so it is actually your first experience with programming, but don't let that scare you. I think it's a fairly easy lesson in the big picture, even though it's a new concept to many students when they get to it at this point. We will dive even deeper into programming later in our Programming Foundations with Python class. But we wanted to introduce this shell scripting because, once again, this overview of system administration, system administrators use scripting all the time to automate tasks. And so it's important to understand that as getting an overview of system administration, but also security researchers and security professionals use shell scripting a lot to automate various functions. At the most simple level, you can think of a shell script as basically a text file that contains a bunch of commands you could have technically typed at the operating system command line. So whether that is the Ubuntu command line, the bash command line, or the PowerShell command line within Windows. And of course, remember on a Mac, it's bash. So bash applies to Mac or Linux, Unix, and then Windows has its own PowerShell. Though, as I mentioned, Microsoft really gotten on the bandwagon of Linux. PowerShell has been ported, and you can run PowerShell on Linux machines now, which is kind of cool in and of itself. But you, in this lesson, the lesson takes you through creating a fairly simple a shell script, but with a little more complexity than just a series of lines you could have typed at the prompt. But that is at its barest minimum. If any time you sit down and do some task as a system administrator or even as a security professional, and you sit down and realize every month I sit down and I type these 10 commands because I'm supposed to do some backups and archiving and stuff. If I'm a system administrator, maybe as a security professional, you're going to run some different scans on your network every month, every week, to make sure that the devices you expect are up and the ones that there's nothing that you don't expect, things like that. So you might have to sit down and type in 5, 10, 12 different commands to conduct these steps. Well, you can keep doing that for the rest of your job, or you can take a few moments after you learn some basic shell scripting to sit down and create a script, which is really just a text file. And you can literally put those 5, 10, 12 commands one after the other into that file, save it as the appropriate file type with the appropriate extension, depending on whether you're talking Bash or PowerShell. Generally, Bash scripts have a .sh for shell script, and PowerShell has a .ps1 extension. And so then you can, instead of when it's time to do those same tasks again at the end of the week or the end of the month, instead of sitting down again and typing a whole bunch of those commands, you can instead type one command to run that script, and that script will go off and do that work for you. And if it's a long enough process, maybe you go to lunch, come back, and it's done, kind of thing. So system administrators use a lot of shell scripting. One of the best examples that I always use, because it kind of, especially folks who have experience in that side of things, if you have any experience in the Windows Server world, if you want to add a user to the Windows Server, you go to the user and group managing utility, manager utility, and you basically tell it, I want a new user. Brings up this nice dialog box. You start typing in their first name, their last name, their department. You give them a username. You assign a password. You set some options, and you click through these tabs. You get it all filled out. You click OK. Boom, you've created a user. Real simple, because it's all just GUI based. You're filling in a form basically. And if you have a new employee added next week, you'll sit down and probably do it exactly that way. But what if your boss comes to you and says, hey, we just bought this company and they have 1,000 employees and we need to import them all, get them all into our system? You're never going to find a system administrator sitting there at that form, clicking new user, filling it out, clicking new user, filling out OK, click. No, it's going to take too long. And if you do find a system administrator doing it, then they need to learn something about shell scripting, because with, for example, Windows PowerShell, you could basically say, okay, boss, okay, I need all their names and stuff in a spreadsheet or text, some kind of export file. And then I could technically write a script that would issue the new user command and read one line of that file each time and get the first name, last name, and everything. And then, of course, you run a script and it zips through all that stuff. And you, once again, go to lunch, come back, and all your users have been imported in. So anytime that you're issuing, some people say as few as more than 5 lines of commands at the prompt again and again, every week, every month, every quarter, then and definitely as you get 10, 20, 100 lines, then yeah, this is the time to sit down and write a script. Now, like I said, at its simplest, you literally can have nothing more than just a couple of lines that could be, that you could have manually typed in. But if that's all it was, that would be useful. But what if we want to do something a little more elaborate? What if we want to write a script that is not just hard-coded to do one thing, but maybe based on some user input could take different action? So like I mentioned, maybe you have to every month archive some files out of a particular folder, and that's kind of what the sample in the lesson's about, is to write a little script that can basically, take certain types of files and back them up to another folder from a folder full of files. And initially, it kind of works through the process. You'll see in the lesson that there's both Bash and PowerShell are demoed. It's good to have an overview of both, as I think I've mentioned to you guys before. As you move on past our program, start looking at whether you're going to go red team or blue team. If you decide to take Pentest Plus after Security Plus, for example, Pentest Plus requires you to have a basic shell scripting level of knowledge of 4 languages: Bash, PowerShell, Ruby, and Python. And in our program, we cover all but Ruby, and Ruby would be fairly easy enough to get that basic level of understanding, to move on to Pentest. And so, but the lesson in this one is just Bash and PowerShell. You only have to do one. You can do both, of course, and encouraged to get a little bit of experience with both sides. But if you have a Windows machine at home, then you can follow the instructions for the Windows side, set up your PowerShell correctly so you can execute scripts, and then be able to just use any notepad or text editor. VS Code works fine, whatever, to write your shell scripts, and then at the PowerShell prompt you can execute those. If you're instead got a Windows machine, or you can just fire up one of your Network Foundation's Ubuntu VMs and use that to use the Bash script and use the Bash PowerShell or Bash shell, Bash command prompt, and then you could write Bash scripts. Now, there is one catch in both things. If you're using PowerShell, by default for security, PowerShell, when you first open it, will actually give you errors when you try to run a script. So pay attention to it in the lesson. There's a specific you have to make your own custom shortcut is usually the best way to do it. You can globally turn that feature off, but if you do, then you open yourself up to risk that you may get a virus at some point, or get some script that executes against you. So instead of doing that, the best thing to do, and I can actually show you this. In fact, let me do a screen share here because this is kind of a critical one. So I'm going to minimize all my junk. And what we're going to find is, where did I put it? Right here. I'm going to move it out here so everybody can see it. You see, I created a bash, a Windows PowerShell icon. It's just a shortcut. You can make shortcuts all different kinds of ways. I'm not going to get into that in our short time left. But instead of just calling it Windows PowerShell, I say Windows PowerShell for scripting. So I renamed that so that I would know. And if we take a right click and take a look at the properties, what we'll see is the key piece. You see that the PowerShell executable is actually in the system root folder, which means basically C:\Windows system 32, Windows PowerShell version 1, and then PowerShell exe. And that is where the standard default icon, like if you find it on your start bar, it'll be that. It'll just launch PowerShell. But you'll see that I've added a space and then a hyphen, which basically is passing in a parameter to PowerShell that says execute policy unrestricted. So I'm declaring the execute policy. It's kind of like, remember in Linux we did ls space -l so that we could see a long listing. Same kind of deal. We're running PowerShell, but we're saying call the execute policy option and pass in unrestricted. Now what that does for you is mean that you can actually run scripts when you launch this. When you do, it'll come up, takes a second to load up the PowerShell environment, and it gives you a prompt. Or of course, it's very much like the old command prompt or DOS prompt. You can still type basic commands like dir, which is equivalent to the ls on Linux. But we of course can go on and write more complex shell scripts. I think, let me see if I can find them. Where did I put them? Test scripts. There we go. So, like for example, here's a simple one. I'm going to just bring up Notepad, which is easy enough to work with here. So we bring up Notepad, and then what I can do, if I want to create a new script, I can just tell it new text document, and then we can change this extension. So that's making a PowerShell script. You would use the move command on Linux to rename your file, or just use the touch command to create new script.sh, for example. And so that way it'll change the icon. It'll be a Windows PowerShell script. But if we take a look at a simple one here, this one is pretty simple. It's like any other Hello World application. It just uses a PowerShell command called write host, in other words, write to the screen, and it writes what we put here in parentheses. If we run this, let me do this. I'm going to switch to my desktop. I'm going to switch to test scripts, and then if we take a look, we'll see that I'm in that same folder, and we can see that Hello World script. So if I say /Hello World and run it, look at what it did. Hello World, it came back. So that's pretty basic. It's kind of like print in Python or other languages. We want to print to the screen, but we can of course do more elaborate things than that. There's an example. I'm not sure what I did. I'm just going to throw it in there. I'm not sure what this was. Oh, well, here's a pretty simple one. So this one, basically, you can see that I took a command like take a directory, and then I ran this other script memory. So if we run that one, for example, test1, you'll see that we got a directory of C:, and then we got it to run. Oh, it's telling us we have to tell it to run. We want to run once, so we'll go ahead and do R, and then it's going to come back and report memory. So, like I said, at the most basic level, PowerShell or Bash are just collections of commands you could write at the prompt. And so I could have typed, to get that exact same output, of course, I could have typed C:, directory C:, /, and then typed the memory and ran it. But instead, I put it all in one script, and then I only have to run one command instead of two. And of course, if that was full of dozens of commands, then you can see how this starts to save you time once you take the time to learn a little bit of scripting and put together your script. But let's look at a more complex script. So like this one, it only comes back with these few lines of physical memory output. But what does that script look like? So if we take a look at the memory script, which is not one I wrote, I got it from a collection of scripts. You'll see here, this Rob made these, so I'm not taking any credit here for this one, but these are just comments. These hashtags or pound signs say that we're not going to print, and then it basically takes the input that you can apparently pass parameters into this program like you can most programs, and then it takes a look to see if we're in our home directory. We're trying to see if we have which kind of slash we have, because remember, you can see this one is Linux. There's mention of Linux. Linux ignores the computer name, so this was written to run on both. And so it runs through, and this is one of the things that the lessons will take you through. Once you kind of learn the basics of programming, every programming language is Bash, PowerShell, Ruby, Python, C, C++, Java, on and on. They all have certain things in common. They have basically a collection of rules of how you're supposed to write their code or their script. That's called the syntax. And then almost every language has basic functionality, like the ability to have variables. So we can use a variable name in place of having select the amount free. $ free here is a variable. In this case, it's a 64-bit integer. That's a data type. We don't have to get that complex in our simple lesson here, but you can and then all languages have some kind of what we call flow control. So we're basically saying, if this condition happens, if the home directory is not equal to a slash, then we'll do these things, else then we think it's Windows, so we'll do these things. But in both cases, we're grabbing or getting some information by running commands to select a string, proc the memory info, get the memory available out, and trim that data. Or in this case, we're getting the Windows management instrumentation object, operating system, computer free memory. And they're actually doing some math here. That asterisk is times. And then, of course, if neither one of those happen, in other words, we don't find Linux or we don't find Windows, then we have an error. All things considered, then it starts writing out these lines, and it just uses like the same host line that the PowerShell, the Hello World script did. And we ultimately get this few lines of output from all those fancy lines of code. But this code was written to run, you could run this exact same script on a Linux machine, and based on the check that it does, it'll figure out whether it's Linux or Windows, and then do it the appropriate way for that OS, and ultimately still return back the results that we're looking for. And so you can see that this is a script that can return free memory on any system. And so instead of having, and plus the person has, set up a nice display here of bytes and kilobytes and megabytes for us, done some math to display that. We could, look in our task manager or run various commands on Unix, like the top command to find free memory, but to have it all available in a nice little format like this, this is what the script has been written for. And like I said, what's very common is that I don't have enough time, sadly, to try to talk about the bash stuff, but it's very similar, and it's all you'll work through. Like I said, you only have to do one. Now, the bash trick, if you have to put that little parameter in to get the PowerShell scripts to run on your machine or a virtual machine, on Linux, when you create a file by default, it usually doesn't have the execute. Remember permissions we talked about in Network Foundations? It doesn't have the execute permission. So you're going to have to use the chmod command to change the permissions of your scripts. All of this is explained in the lesson. There's just a couple of key points. I've had students go, I got a beautiful script written, but it won't run. And it's one of these two things that they overlooked or missed. So make sure you follow the instructions in the lesson. As you work your way through, pick a language. So either use PowerShell if you want to use Windows, or fire up, a VM if you want to use Bash on Ubuntu, or if you want to, I think you both are on Windows in this class at this current session, but if you had a Mac, you could just fire up the terminal and be using Bash there. But pick one of the languages, work your way through the example in the lesson, and then you're going to find in the exercises you're asked to go further and add more functionality to that. And everything should be pretty straightforward from there. So then to try to wrap up in a very short number of minutes, because I have another workshop after this, we technically have 2 more lessons to cover. But thankfully, they're pretty conceptual and kind of your first exposure to some of this stuff, especially in lesson 6. But it's not going to be your only. We're going to come back to these 2 topics quite a bit. Lesson 6 is on vulnerability and penetration testing. And the one thing I always point out in this is that they are not the same. Vulnerability assessment or vulnerability testing is the act of testing a system, an application, a server, or a device to see if it has any vulnerabilities. And if they are found and reported, um, a step of that, maybe that's pretty much the end of it. We ran a certain scan, we ran some certain test. It seems to be that we're vulnerable to a SQL injection or a buffer overrun, or we have an out-of-date, unpatched software here, or whatever the vulnerability is. If your job in cybersecurity is to do a vulnerability assessment, you will run the test and then report those findings. A pen test is a different beast, only in that a pen test attempts to validate and take advantage of any potentially discovered vulnerability. So yes, pen testers will most of the time have to do their own vulnerability testing, but that depends on what type of pen test it is. In the field, there's these phrases, black box and white box test. A white box test means you know everything about it. So maybe you're an internal pen tester. And so your blue team, your defense folks have already done some scans. They did some vulnerability assessments and they turn those over to you. And they say, hey, go check and see if these are real. Can you really get in? Is there any risk there? This is what our system is reporting, that this is out of date, or this could be an error, could be an issue. If you're doing a black box test, like for a third party client, like I might do, they're not going to have run a vulnerability. They're going to say, hey, test our stuff. And I'm going to go run my own vulnerability checks and decide which ones of those I want to focus on trying to actually penetrate. The idea that a penetration test takes that next step to actually exploit a found vulnerability. And then, of course, unlike a hacker who at that point get in, take control, steal data, do whatever, we would, as a pen tester, stop and report that to the client or the blue team and say, yeah, you gave me that list of 6 vulnerabilities that your scan showed. I tried to get in, and 2 of them, a bunch of them I couldn't. Maybe there's some other mitigating factor. Maybe the firewall blocked it, whatever. But on 2 of the cases, I could get to a command prompt, or I could get to those data files. I could get access to the database. And so you report that. And then ideally, that's the whole beauty of red team, blue teaming, is that within an organization that the red teamers will help the blue teamers get better, because they will help validate those possible vulnerabilities and then give them recommendations on how they're going to mitigate that. Are they going to have to put up new firewall rules, block certain reports, upgrade software, patch something, customize something, etc. So lesson 6 is an overview about vulnerability and penetration testing. I won't spend much time on it. It does talk about some of the tools like Wireshark and Nmap, Kali stuff. This is, once again, kind of an overview, and even system administrators need to know this, because once again, we interact, the security team and the system admin teams, a lot. And so, in a white box test, then the system admin team is going to know security is doing certain testing. In a black box test, it's entirely possible that a company would hire an outsider like myself to come in and do a test and then not tell their team that the test is going to happen, because they want to check how their team responds to this potential, probing and potential breaches that are happening. And so, but we'll talk much more. We're going to come back. Of course, it's kind of just a quick overview here, because next class, network defense, you're going to learn, even more about how to actually do some of this stuff. We're going to run some vulnerability scans, both at the command line and using a web-based tool called OpenVOS. We're going to look at the output and reports of these, so we can, start to rank and classify various potential vulnerabilities that we might exploit. And then we're going to learn how to exploit some vulnerabilities. We're going to learn how to do password cracking. We're going to learn how to do SQL injection. And so we're going to continue to learn much more about, matter of fact, we have whole lessons on both of these topics in the next class on vulnerability assessments and pen testing. And we will cover it again in later courses, and we'll touch on it in different places throughout the program, as they're kind of some of the bread and butter of what we do in our field. So I won't spend a whole lot of time on 6. And that leaves me just in my last few minutes here to wrap up on lesson 7. Lesson 7 is called Secure Protocols. And we've already covered a lot of protocols in Network Foundation. You obviously had some knowledge of some of the basics, HTTP, TCP, IP, and learned about it or reviewed back in that class a lot of others, mail and SSH and FTP and Telnet and all these ports, all these different protocols for different purposes on the internet and on corporate networks. If you really want to summarize lesson 7 is all about secure protocols or securing protocols. And in a nutshell, it basically means use the secure ones. So for example, if we need a remote shell access to a machine, like a server up in the cloud, we're not going to use Telnet. We're going to use SSH. Telnet is an unsecure protocol. It goes way back to the earliest days of the ARPANET and the internet as a way for a remote user to access, say, a mainframe, which was a big reason the net was even created, to share those resources around the country between different researchers and defense contractors and universities that were part of the system. But those were innocent days, because all you had to do was be at one end or the other with a packet sniffer like Wireshark, and you see those telnet packets go by, and you bore down into your Wireshark information, and you see the username and password in clear plain text. That's not secure. Anybody along the way could steal that data. So telnet, for the most part, has gone by the wayside and been replaced by SSH, which, like HTTPS, uses public-private keys, like you learned in Network Foundations, and creates a secure encrypted channel between the client and the server. So if you're tasked with, okay, we need to implement X, Y, or Z, then if there are options, then you use the secure protocol. Now, the other thing is, though, occasionally you'll run into, say, maybe you have a legacy piece of equipment on your network that uses Telnet to access, and you want to have some kind of remote access to it. Well, you don't want to just throw that up on the internet. Once again, somebody might be able to capture, or they can attack it, things like that. And so one of the things is that you might use some other technology, some other secure protocol. One of the things that I've seen, for example, most people use virtual private networking either to, home users might use it to obfuscate their location. It's very common for people outside the United States to use a VPN service to make it look like they're in the United States, so they can access websites and services like Netflix or others that are geolocation based. But it's also common for remote users of a company to use VPN to create a virtual private networking encrypted connection back to their home office. Well, in the case of, say, some old legacy piece of control equipment on the manufacturing floor that uses Telnet, you don't want to just have Telnet open to the whole world, because somebody could sniff those passwords. And so, but maybe you still don't want to have to go to that floor to manage that device. You want to be able to get there. Well, I've seen companies set up internal VPN connections so that admins can connect to that segment of the network, and then telnet into that device, so that it doesn't, that the rest of that is across the network, across the net, from home, wherever it is, that's all encrypted. It's just that last hop that's securely on a segment that they control, to allow them to get in. So in a nutshell, secure protocols are about using the secure version of a protocol, securing them appropriately by configuring them appropriately. And if you do have to, for whatever reason, use an older unsecure protocol, many times you end up wrapping that in some other protocol like VPN to encapsulate it and thus add security back to an unsecured protocol. So I'll leave you to read most of 6 and 7 on your own. Good overviews. You'll spend most of your time this week playing with your shell scripting exercise, I assume. If you have any questions, of course, let me know. I'm running a little late and I got to go do the next session. So thank you as always, and we'll see you folks later.